Hi Year 12s! In this video, we will look at inverse functions. Inverse functions are only defined if the original function is a one-to-one function, which means that every point on the x-axis only corresponds to one point on the y-axis. The easy way to do a quick mental check of whether something is a one-to-one function is by seeing if you could draw a straight line up and down the graph, and you would never cross the function twice. In these two examples, a quadratic and a linear, you can see that this passes the test. But this function does not. In fact, we've already seen an inverse function in our exponential and log functions. For example, let's find the inverse function of f of x equals e to the x. First, we need to check if it is a one-to-one function. Using our simple test from before, we can see that it is. As such, it can have an inverse function. First, change f of x to y to make things easier for ourselves. To find the inverse, we swap our x and y values. Now, using log laws, we can rearrange to get y by itself. Now, if we were asked to do this in the exam, to get full marks, we need to make sure that we go back to using the original notation. We use f to the negative 1 because that is the notation for the inverse, giving us f to the negative 1 of x equals log base e to the x. We can also see that the inverse is simply a reflection of the original function, in the black line y equals x. Here, the inverse function is shown by the red function g of x. From the graph above, we can see that when the function is flipped to the inverse function, the new domain becomes the old range, and the old domain becomes the new range. For instance, the old domain for the function is all real numbers, and now the range for the inverse function is all real numbers. Let's take a look at a 2014 Exam 2, question 6, which is a multiple choice question. We know that there can only be an inverse function if the function is a one-to-one function. We can see that as x approaches infinity, the function will approach infinity. Since it is a positive cubic, it will start at negative infinity and go to infinity. If it has a point of inflection, then it will be a one-to-one function. Therefore, we should first determine that. We find the point of inflection by finding the derivative. If you need help with deriving this function, check out our calculus page on power and exponential differentiation, making it equal 0 and solving for x. So, f dash of x equals 6x squared minus 18x minus 168. We can take out the factor of 6 to get 6 outside of x squared minus 3x minus 28. We are now looking for two factors which add up to negative 3 and multiply to negative 28. We can work out that they are 4 and negative 7. Therefore, we'll have a one-to-one function for three different sections of the graph. From negative infinity to negative 3, from negative 3 to 7, and from 7 to infinity. Only one of those are the same as the above, which is the domain from 7 to positive infinity. This is B in the multiple choice, and our answer. Good luck with your studying!